Okay, Mark thought it would be a good idea if I made a video of this to show this, because he's never actually seen one personally, and I don't think I've ever run into one. This is a Robyn SB-520D. If you're familiar with this radio, or actually I should say if you're familiar with the old version President Washington's, you will be very familiar with this chassis. It's just a standard Uniden chassis with a UPD 858 PLL. Now, the problem. Get this screw out of here before it falls in. Customer purchased this not sight unseen. He saw it, but had no idea if it worked or not. And before I thought I'd get into the replacing the caps, I thought I'd just check to see how it was working. Had really good AM power, but low sideband. Had about a maximum of about 6 watts of power output on sideband. So I thought, well, I'll just do a couple little checks before I get into doing the refurbishing this completely to see what the heck's going on. Well, of course, this was a screwdriver special. So both bias pots were cranked the whole way. The AM power levels cranked the whole way. Basically any pot you could turn full clockwise to get more power or swing, yeah, somebody did that. To include, I did find the one over here in the power supply, right down there, hiding behind those wires. That little guy. Yeah, the power supply was set at about 16 volts. So in any case, first thing I did was, because the bias pots were both cranked the whole way, I thought, well, I'm going to check the bias current. So on these, to check the bias current, pull this wire off, and you stick your current meter, your amp meter, in series with it. And this one's for the driver, and then this one is for the final. And I checked the driver, and of course, yeah, it was way, way, way too high, because like I say, both the pots were cranked to the max. So I adjusted this one back down to where it was correct. I came over to the final one, pulled it off, and it was just about 3 amps, 2.9 something. You might as well say it was at 3 amps. Way too much bias for the final. I thought, what the hell is going on here? So I started doing some measuring and testing, and that's when I emailed Mark. It's just been, I guess you could say, one of those, I don't know, I always seem to get runs of these things, oddball, strange problems. Like the last radio I worked on was a Cobra 2000 with, Christ, there was probably a dozen damn IF cans in that thing. I've replaced all of them in the receiver circuit, and yes, almost every single one of them was bad. It's been one of those runs. Well, this is another one. So like I said, I get to checking a few things, and I pull this resistor. Now this resistor is the one that hooks up to the 8-volt transmit rail to supply voltage to the base of the final transistor. So let me grab the schematic. This thing cracked open here. Okay, so I pulled R180 right there. So you can see 8.2 volts in transmit, okay? Yeah, and they have a really wonky, even Mark said, yeah, he never figured out what the hell they were thinking when they designed this bias circuit. Well, in this radio, you don't need a bias circuit. You quite literally could cut it here and here, which is what I'm going to show, and the radio works just fine. Because what I did was I pulled that transistor, and I still had voltage at this point right here. So I removed R180, pulled this resistor, and I still had about 0.7 volts here at R157. And what the hell's going on with this thing? I pulled R179 and L44, and I still have 0.7 volts on the base. So finally I got to the point I actually pulled, I had, if you remember, I said I had 6 watts of power output in sideband when I first checked the radio. As soon as I removed this resistor right here, R180, my output power went up to about 16 watts. Put that resistor back in, power dropped back down to 6 watts. Remove this, so I'm removing the bias voltage here. By removing that resistor, the power went up. yeah, it shouldn't be able to do anything with no voltage. So in any case, so what I have right now is this resistor is pulled, and I want to show this. This resistor is pulled, this coil is pulled, L44, and so is this resistor. So if we look in here, so there's your bias diode. But this resistor, if you look down in here, there's one here. This one would normally be right on the other side of it. I'll show down in there. Look. You can see right there's the holes, right there and there, where our 180 would be. I also have, you can see the leg of our 170, I think it was 179, without pulling the schematic back out, but right there, that's disc pulled out of the hole. Here's coil L44. So the bias circuit is completely disconnected from this transistor. And what happens? So let's get that light shine back out of the way. Turn the radio on. We're in upper sideband. Audio. Audio. And we'll swing over here to the watt meter. I'm not going to get too fancy flipping the camera around, but just so you can see. So right there. Audio. 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 That's a 50 watt scale. So straight up is 15 watts. Audio. 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 Yeah. Maximum smoke with no bias circuit. Here it gets even better. So let me turn it off. My connector hook back up there. Yeah, I actually had in the process of putting a new transistor in here. There's the there's the new final there. I actually had it gooped in when Mark emailed me and said, you know, you ought to make a video of that. So, power supply off. It's flipped up here real quick. Out the suck-o-matic. Now, it's not going to transmit because what I'm doing is lifting the base of the final. So with the base of the final lifted, there should be absolutely, down in here, with the base of the final lifted, there should be absolutely, just broke. It's just hanging on by a hair. You can see it there. Oh. I'm not sure how well you can see it or not, but there's actually, that's the base right there. It's hanging on by a hair. It just fell off. It broke off, which is fine because the transistors, like I say, I'm going to turn the power supply back, my AC power supply isolation transformer back on. Turn the radio on. Now, we're going to hook up a voltmeter. So there should be absolutely nothing on the base right now because the base is not connected to anything. Probe tip here installed here. Let me get this. I'm going to have to. Yeah, well, I'm just going to have to get this down in here. Okay. Okay, so I now have this probe attached to the base that is no longer connected to anything in the radio. And I key the radio, and 0.6, 0.5, it goes down, it goes up, yeah. It is a leaky transistor. Are you frigging shitting me? Like I said, just another one of those radios, and I always seem to get these things in runs. I can't just get one radio. It's a pain in the neck to diagnose. I've got to get several of them in a series, so Lord knows what will be up with the next one. So, new final. But so there you go, Mark. There's a self-biasing transistor, and yes, people, that's basically what the final transistor in this radio is doing. It is this radio actually has full output power in sideband with no bias circuit hooked up whatsoever. The transistor is basically self-biasing itself. Because like I say, I had 6 watts peak power in sideband with the radio hooked up correctly, with the bias circuit completely unhooked, nothing connected at all in the bias circuit. I had 16 watts. So there you go, a self-biasing 2SC 1307. Yep, first time for everything. And of course, as soon as I shut the camera off, I just noticed something else I have to do. Now I have the AC power supply right there turned off. It's safe for me to touch this, but okay, AC line cord. I always tell people it's always a good idea to change your safety bypass caps. And here's a good example. So there's your power cord, comes into the radio. One goes to this terminal, one goes to this terminal. So you've got one capacitor here goes to ground, and then one here to ground, because that one goes down to that stud down there. So that one's strapped down to ground right here. What do we see wrong with that capacitor right there? If the camera wants to focus on it, it's got a hole blown in the side of it. Right there. There's a gigantic black hole. Yep. Another radio needs its caps changed. So, like I always tell people, this is a good example of a radio that anytime the radio is plugged in, now not all radios are like this. Some of them will have the AC line will go to your power switch, so you have 120 volts at your power switch, and then come back and get distributed through the radio or whatnot. But radios like this, which a large majority of electronics are wired like this, the power lines come in and you'll see these caps right here. So that means anytime this cord is plugged into a wall, these components are in circuit. So they're absorbing all the power line surges, spikes, all that nasty shit that happens in your AC power line. And that's what happens to them after decades of being plugged into a wall, even in the off position. So this radio could have been brand new, took it out of the box, plugged it in the wall, never turned the radio on, and that right there can happen. Because like I say, these capacitors are always hooked up. 24/7, 365, they never take a vacation. So, just wanted to show that, and I'll tack that on to the end of the video.